Hi everyone, and welcome back to the channel. Today we are solving the leetcode problem. Find Kth bit in nth binary string. We are given two positive integers n and k and a binary string s, which is formed as follows. Initially, the string equals the character 0, and then all subsequent string will equal the previous string followed by 1 and then followed by the previous string inverted and reversed. And this is for all I greater than 1. So let's take an example here. Initially is equal the character 0, then the next string will equal the previous string followed by 1 and then followed by the previous string reversed and inverted. Let's move to the next example. S3 will equal the previous string S2 followed by 1 and then followed by S2 inverted and reversed. So here we are given a recursive definition of a binary string. Each string is built from the previous one, and the previous string is followed by 1 and then followed by the reversed and inverted previous string. The brute force algorithm here is to build the string using this rule and then return the character at position k. So, for example, if n equal 4 and k equal 11, the brute force algorithm is to build the entire string and then return the character at position k or at position 11. But there is an important thing to notice here. The string is growing exponentially. So as you can see, string 1 had a length of 1, string 2 had a length of 3, string 3 had a length of 7, and string 4 has a length of 15. So building the string directly is inefficient and unnecessary. Instead of building huge strings, I'll show you a smart iterative approach and I'll dry run it step by step so the idea becomes crystal clear. The key observation here is every string has a very special structure. The middle bit is always 1, as here and here and here. The left half is the previous string and the right half is a mirrored and inverted version of the left half. So the idea here is that we don't need the whole string. We only need to know where the index k falls in the string. Is it at the middle of the string or at the left or the right half of the string? So let's take an example to understand how to solve this problem. Imagine that we have n equal 4 and k equals 11. So the s for string will equal this string. the length of the string at level 4, where n is equal to 4, equals to 2 to the power n minus 1. So for n equals 4, then the length of the string will equal to 15, which is 2 to the power 4 minus 1. And as we know, string 4 equal string 3 plus 1 plus reverse and invert of S3. Let's plug this string down here again. So the middle position of this string will equal to 8. And since k is 11, which is greater than the middle, we are in the right half of the string. And when we go to the right half, two things happen. We mirror the k index to match its corresponding in the first half and flag that we have one bit flipped. So we will need to mirror position 11 around the middle, which moves to position. So k equal 11 in the right half, and k is equal to 5 in the left half. So as you can see, this is the middle one, and I think it's going to be clear here. This is a string S4. Here, position k equal 11. Here is the middle 1. So this position is mirrored 2 or 3 places from the middle. So 3 places to the left, right to this position. And if you count from the first, 1, 2, 3, 4, 5. So k equals 11 in the right half is matching the k equal 5 in the left half, but we have a flag, let's call it flipped. Set it to true. So now it's like we having another or a different smaller problem where S, we work now on S3. We don't need the whole string currently because we have mirrored and flipped. So imagine now we have a new problem where S3 equal this string and k equal 5. Again, the middle position at this case will equal to 5, and our current k or index is 5, which is again in the right half of the string. So once more, we mirror the index and flip the flag. So the new position Now, here's position 5, which is equivalent here to position 3, where of the left half of the string, which is currently S2. So S2 will equals string, and the new K will equal to 3. And let's flip again our flag. Again, the middle position equal 2, and the index or K is still in the right half, so we mirror the position. K will equal 1, and we toggle our flag to true again. Now we have reached the base case where is equal 0 and K equal 1. So which is simply the result should be 0. This is the original bit, but we have flipped it an odd number of times. So after applying all the flips, the final answer will become 1. Because if we have 0 and flipped it 3 times, gonna be 1, 0, 1. So let's move into the code. Again, instead of constructing the string, we keep shrinking the problem size. Whenever we move to the right half, we mirror the index and toggle our flip the flag until it collapses to the base string 0. And based on the flip count, we return the final answer. So in the code, first I'll define a Boolean flag. Let's call it flipped, and I'll set it to false. Then I loop while n is greater than 1. I'll calculate the mid position using shift left or the exponential. Both should work. Then I'll check if k equal mid. Then I return immediately. Why? Because as per the program description, the middle position will always be 1. So all I need is to know how many times I have flipped or the count of the flipping. So based on the flipped flag, I'll just return either 0 if it's true or 1 if it's false. If k, let's implement the condition where k is in the right half, as we have seen in the examples. First, I need to mirror k to its position in the left half. So this is the mirror equation. And I'll invert the flip. That means that we have one flipping here. And that then don't forget to increment, decrement, sorry. Finally, after the loop, we will reach the base case where s1 equal character string, the character 0, and at that point, I return also based on the flip track, but this time, if it's true, I'm gonna return 1 else 0. Let's run it to make sure it's error-free. Okay, all the test cases pass. Let's submit it. So in terms of complexity, this algorithm is the linear algorithm. So complexity is of n, and the space complexity is constant. So it's O of 1. If this explanation helped you, don't forget to like the video and subscribe to the channel. Thanks for watching, and I'll see you in next problem. Bye.